Do you want to know how to provide a stable pressure in a staircase that has no external partitions? Or maybe you want to know how building height affects the pressure distribution. If you design, install, or sell overpressure systems and need to learn about our system, you are in the right place. If you are dealing with unusual facility, a high-rise one, or one where standard solutions don't work, and need a support from experienced experts, then this webinar is for you. If you want to be sure that your system will work properly at the time of need, we'll be glad you joined us. I would like to welcome all of you to the Smay webinar on pressure differential systems. My name is Radek Sikorski, and I am Technical Support Manager in the Export Department of Smay company. I am your first contact in case of any technical issue. Contact with me means reaching the knowledge and experience of dozens of engineers who have been and are creating SafetyWay system. Smay company has been creating pressure differential systems for over 13 years. During this time, we have developed many cutting-edge solutions, always being at the forefront of innovation. Today, SafetyWay system ensures the safety of hundreds of buildings in Poland and Europe. Before I get to the clue of our meeting, I would like to provide you some organizational information. The webinar will last about 40 minutes. It will be recorded, so every participant will receive it later via mail. I invite you to ask questions in the chat. Our technical team will answer for them during my presentation. For your convenience, the chat is moderated so that questions and answers appears at the same time. So let's begin. First, some theory. Do you know that the temperature of fire is estimated to be direct cause of death during fire in only about 20% of cases? The main cause of fire deaths, making up about 65 to 80%, is smoke poisoning. Smoke spreads quickly, significantly reduces visibility, increases panic, make evacuation difficult, and also make it difficult for rescue teams to reach source of fire. Safe evacuation requires visibility of at least 3 to 5 meters if you are familiar with the building, and 50 to 20 meters if not. Meanwhile, dense smoke can reduce visibility by up to several centimeters, making evacuation impossible. For this reason, the law often requires escape routes to be protected against smoke penetration to increase fire safety. To do this, a certain amount of air must be pumped into the stairwell space. Air will escape through all possible routes, through open doors, through gaps around closed doors, through leaks in walls, through windows, etc. And therefore, in the design process, we need to determine all leaks in order to select proper air volumes. By supplying the right amount of air, we achieve and maintain an overpressure, for example, 50 Pascal. This is necessary to prevent smoke from entering the stairwell through the gaps. When the doors leading to the fire floor are opened, the pressure drops and smoke can get into the staircase. To prevent this, the system has to increase the air volume so that a certain airflow velocity is achieved on doors to counteract the inflow of smoke. This ensures that escape routes remain smoke-free and evacuation is possible. It is very important to remember to provide an air release path from the fire floor. Without it, the flow criterion will not be met. It can be mechanical smoke extraction, a gravitational shaft, or an automatically opened window. What's more, different spaces can be protected depending on building architecture and fire regulations. Usually they are staircases, often lobbies and elevator shafts, less often corridors. I'll tell you later how to approach each of these. But before we move on to design examples, a few words about design standards. The current design standard is EN 12101 Part 6. This is a standard that specifies both design requirements for systems and product requirements for equipment. There is a work underway to separate these functions. According to the drafts of standards 12101 Part 6 and 12101 Part 13, the first one is to remain product only, while Part 13 will specify design and commissioning requirements. Work on these standards has been going on for about a decade now, but the members of the working group, of the technical committee, of the European Committee for Standardization anticipate that the publication and official introduction of those documents might take place at the end of next year. Currently, they are out for international consultations. Draft of 12101 Part 13 introduced many changes. The most significant of them are shown in this table. The acceptable range of pressure in the stairwell has been increased from 50 Pascal plus minus 5 Pascal to a minimum of 30 Pascal, while the maximum will be set by the criterion of 100 Newton of force required to open the door. The system divisions, air velocities in the airflow criterion, and response times for dynamic systems have also changed. For example, in the current standard, we have 6 classes of systems. They differ in the purpose and place of use, the functional requirements, and configuration in which these requirements are to be met. So we have System A for residential buildings where defense in place is possible. System B is used to allow firefighting crews to take action to fully developed fire. System C is for simultaneous evacuation, used, for example, in offices, universities, or theaters. System D is for buildings where there is a risk of slips, such as hospitals or hotels. System E is for phased evacuation, for example, in prisons or hospitals. And System F is rarely used in specific buildings, for example, industrial ones. For many designers and fire consultants, system division is quite complicated and causes difficulties at the concept stage to choose which class should be applied and how it should be applied. For this reason, only 2 system classes were included in 12101 Part 13. The configuration of both is exactly the same. The only difference is the air velocity achieved in the airflow criterion. The guidelines for using one or the other system are also very clear. If you have low or medium residential building, or building equipped with water extinguish system, or if your fire authorities agrees, you can use class 1. In any other case, you have to use class 2. An important provision that is repeated in both standards is the one about alternative solutions. It makes the standard functionally oriented, meaning that it allows for alternative design solutions as long as the functional requirements can be met. It is very useful, especially when you are dealing with an existing building and don't have opportunity to make a lot of changes in the architecture of building. One remark, please note that since 12101 Part 6 is still valid standard, and it is still unclear when the new standard will become mandatory, whenever I refer to the standard during my presentation, it will be always current 12101 Part 6. How to achieve the correct system functionality? There are 2 approaches to pressure differential systems. Traditional systems are based on fans with constant flow and mechanical pressure relief dampers located on the roof. It is still a very popular solution. In those systems, the air volume is selected for the airflow criterion, and when the door is closed, the pressure relief damper releases the excess air. Second approach is to dynamically control the supply airflow depending on the criterion that is being met at the moment. When all the doors are closed, the device aims to maintain an overpressure of 50 Pascal. When the door is open, the pressure in the stairwell decreases and the fan increases the amount of supplied air to reach the airflow criterion. Such systems do not need a pressure relief damper. This is our approach. This is my approach because it is much more flexible and in some weather conditions much more reliable. I'll show you later why. We had a great opportunity to develop our system in real-scale testing lab. In cooperation with top specialists of Warsaw and Krakow Universities of Technology, we have used a 90-meter high structure of an unfinished skyscraper from the 70s, popularly known as skeleton, to test different innovative solutions. The aim of studies was to develop a system that would eliminate the negative impact of the stack effect on the pressure differential system. The research took 2 years, so we tested our solutions in all possible weather conditions. The result of our work was a safety-way system based on iSWAY pressurization units. I'll show you later how this building looks like today, but first I'd like to show you the video demonstrating our iSWAY device on example of staircase in a shopping mall.
Pressure differential systems. iSWAY type compact pressurization unit, construction and use. The solutions of the Smay company, based on iSWAY compact pressurization units, are applied in various types of buildings, but also in buildings where simultaneous evacuation is carried out, for example, in shopping malls. During this evacuation, pressure differential system has to respond dynamically to the changeable demands resulting from the actual stage of evacuation. In these such buildings, staircases are often located in the internal part of the building and may operate selected floors only. There can be other rooms above them, which is why it is impossible to install barometric overpressure dampers. At the same time, the system has to cope with the problem of great variations in airflow supplied to the staircase. During the realization of pressure criterion, the airflow is small, and during the evacuation, the required flow is even 10 times bigger, which poses a problem in the precise control of the system. In this case, a simple pressurization system may not fulfill its role because it is exposed to great variations in the conditions of operation, which may result in the oscillations of the system and, as a consequence, may endanger the evacuating people. For example, the oscillatory increase of pressure to 150 pascals will increase the required door opening force to 200 newtons, which will hinder its opening. The power necessary to open the door drops below the required level of 100 newtons, which may last from 10 to 20 seconds. The staircase will be cut off from the evacuating people. In order to preclude such a situation, the Smay company suggests the use of modular solutions based on iSWAY compact pressurization units with extra fast-acting automatics based on predictive algorithms that identify the object of regulation. The units are small and light, which allows to install them in any place in or outside the building, both in a vertical or a horizontal position. The main components of the iSWAY unit include an air supply fan, measuring board enabling continuous measurement of the actual airflow rate, shutoff damper, smoke detector, differential pressure sensor, frequency inverter with the fire mode function. Control is performed with a state-of-the-art controller provided by the Plume company. Constant monitoring of electrical circuits, supplemented with automatically performed periodical functionality tests, confirms continuous standby mode of the iSWAY unit. During these tests, the shut-off damper opens and the fan operates at low frequencies for a few seconds, which confirms that the system is operative. The data acquired during such tests are recorded in the memory of the device, and the reports can be additionally printed. Tests are repeated every 24 hours. They take a few seconds and do not affect the regular business of people using the building. In order to ensure reliability of the device placed outside the building in all weather conditions, the iSWAY units are equipped with an anti-frost system, which counteracts the freezing of the specifically structured shut-off dampers. Owing to this solution, the system can be activated when the ambient temperature drops below 12 degrees Celsius. If the device does not pass the 24-hour tests, the indicator will switch the panel on and the alarm message "General Failure" will be sent to the fire alarm system, which will enable a quick elimination of its cause. When fire breaks out and smoke activates smoke sensors, this information is transmitted to fire alarm control and indicating equipment, which switches iSWAY unit on. Information about switching on iSWAY unit is then transmitted to TSS board. If there is a fire in the building, the pressure differential system will be activated, producing set value of the overpressure inside the staircase, for example 50 pascals. After opening the door to the staircase, the pressure will drop and, as a result, the unit will increase the air supply rate. Owing to the use of fast-acting adaptive automatics, the unit immediately adjusts its capacity to the actual requirements resulting from evacuation stage. The reliability and efficiency of the iSWAY devices are attested by the technical approval and the certificate of conformity.
In this slideshow, we can see available types of iSWAY device. We have standard FC compact unit and two ductless versions, roof-mounted RFC type and wall-mounted WFC type. As you can see in this table, all of them have a very wide operating range. Obtaining such low minimum air volumes is possible thanks to a predictive algorithm based on neural network for constant learning. Basically, from the first cycles of operation, the device remembers what frequency it reached in which event configuration. Thanks to this, after detecting a sudden change in the pressure, the device immediately knows that the criterion has been changed and what value of frequency it should reach. Physically, it is accomplished with inverter and braking resistor. With these three components, our iSWAY can go from very high air outputs to very low in less than 3 seconds. And now I'll move to examples of design solutions, starting with low and mid-rise buildings. Systems for them are not complicated. Depending on height of the building, they can be supplied with the single point for buildings lower than 11 meters according to the standard, or they can be multi-point supplied if higher. In this illustration, I have shown the location of units on the roof. It was because this is where architects usually locate technical equipment. But please remember that it is always better to locate them on ground floor to avoid smoke suction. In the case of location on the roof, the standard recommends the use of double air intake system. As I said before, our iSWAYs don't require a pressure relief damper. This is especially useful in staircases without external partitions. For example, those serving underground floors. And another big advantage of our system is the possibility of auto-adaptation. Thanks to variable flow and the predictive algorithm, the device is able to calibrate itself to maintain the set pressure, even if the degree of tightness of the staircase or the adaptation of the floor and therefore the resistance of the air release path have changed. There is no need to manual recalibration like there is in mechanical systems. Our system with multi-point supply was used in Marriott Hotel on Malta and in hundreds of other projects as well. This system can be used in practically any type of buildings. The situation changes when we talk about staircases in high-rise buildings. In such situation, the stack effect has a very significant impact on the pressure distribution over the entire height of the staircase. The stack effect, called also the chimney effect, is the effect of heating or cooling internal air. Due to the difference in density and convection moves, the air goes up or fall down depending on the season, causing a pressure difference. What is interesting, the supply of large outside air volumes during the pressure differential system operation moves the pressure range, but doesn't change the pressure difference between the top and bottom of the stairwell. The reason of this is the large heat accumulation capacity of the concrete walls of staircase. They give or take the heat to or from the fresh air. This can cause problems with door opening when overpressure system is operating. This is proven on basic calculation, CFD simulations, tests on real objects, and by years of experience of anybody who worked with pressure differential systems. Of course, this is only simplified illustration of the process, and in traditional systems during the winter season, this effect will be partially reduced on the top floors by pressure relief damper located on the roof. But the problem is very significant at very high building and at high temperatures, such as those in warm climate. The solution we developed for high-rise buildings is to use flow system. Flow system consists of two reversible units. One of them supplies air, and the second one extracts it. In this way, we take advantage of the staircase airflow resistance to compensate the natural pressure gradient. The airflow achieved in this way, in combination with dynamically adapting fans, make it possible to achieve even pressure distribution throughout the entire height of the staircase, and to eliminate the risk of exceeding the required force to open the door. The big advantage of this system is that this is effective under all conditions, regardless to the external temperature and immediately after activation. If you want to learn more about the stack effect and our flow system, I invite you to watch our video about it on YouTube. This system was adopted, among others, in Sky Tower in Wrocław or in Złota 44 in Warsaw. The next group of concerns are fire lobbies. Sometimes they are supplied by transfer dampers from the staircase to achieve resultant pressure value, while according to the standard they should be supplied by a separate system. The problem is that they are very, very small, so the air volumes needed to achieve the pressure difference criterion is also very small. Meanwhile, the airflow criterion for the speed of 2 meters in system B usually require 15 to 17,000 cubic meters per hour. And this is where the wide operating range of our devices that are able to achieve both values comes to help. There is no need to artificially unseal the lobby, and there is no need to install additional dampers. The situation is a little different when it comes to smoke removal systems. Please remember that such installation must always have air compensation to avoid the risk of under pressure in the corridor or accommodation. This can be achieved by automatically opened compensation window or through additional shaft. If there is no possibility to locate them, then the air transfer damper equipped with multi-blade smoke control damper can be used. When the door is closed, air passes through the transfer damper, but when the door is opened, air will always take the path of the lowest resistance, so it will pass through the door and airflow criterion will be met. On this picture, you can see how such damper looks like. As you can see, it takes quite a lot of space. So what to do if we don't have a lot of space? Nowadays, it is very common to make lobbies as small as possible to maximize a commercial area. It is also very common that the architect doesn't allow to locate traditional air transfer damper due to aesthetic reasons. In such situations, electronically controlled air transfer can be used. This is a solution based on two fast-acting dampers, which, based on electronic pressure measurement, direct the air into the lobby or into the corridor. When the door is closed, some part of air is directed into the lobby just to keep 45 Pascal inside, while most is directed into the corridor to compensate the exhaust. When the door is opened, total air volume is directed to the lobby to achieve the airflow criterion. This is how the air supply inside the lobby looks like. This solution has some advantages over traditional transfers. We can use less air volume, so device and shafts can be smaller. And we can use cheaper one-blade smoke control dampers instead of multi-blade. If you like to learn more about this system, again, I suggest you to check on our YouTube channel. Electronically controlled air transfer were used, among others, in Unity Tower in Krakow. This is the building that was built on steel construction of skeleton, the same building we used for real scale tests. As you can see, we put theory into practice, and this building is also protected with flow system. Another example is corridor smoke extraction. Sometimes national regulation require corridor smoke extraction. Sometimes the smoke extraction is used as air release path for pressure differential system. If there is no space for compensation windows, natural compensation shaft or air transfers, traditional or electrical one, there is possibility to supply makeup air with additional iSWAY. The air can be supplied with a very small shaft, much smaller than for natural compensation. Unit for lobby operate on minimal air volumes to keep set over pressure, for example 45 Pascal. And when someone open door, the unit increase the rotary speed and compensation iSWAY decreases its airflow. As a result, most of the air will pass through the door, achieving the airflow criterion. And the last design example, elevator shafts. They can be supplied from one point if they are lower than 30 meters and from multi-point supply if higher. In both variants, we take measurement in the middle of shaft to control the system on basis of average pressure shaft. This supply method causes wider pressure gradient, depending on height and temperatures, of course, even up to 30 Pascal to each side. But to be honest, it doesn't influence safety as much as it would in staircase. And for that reason, fire authorities usually agrees for such pressure range. If you want to achieve pressure range within the limits required by the standard, which is plus minus 10%, we can also use two reversible units to control pressure precisely. Let me present another of our references. Office building Warsaw Spire with the height of 220 meters is also equipped with our SafetyWay flow system. And the last reference building I wanted to share with you is Warsaw Tower in Warsaw. Currently under construction, it is already the highest building in Poland and also in the European Union. If you wonder how to start cooperation with us, or if it will be beneficial for you, I invite you to check it out by contacting us. We provide comprehensive support for our clients at each stage of a project. We assist our clients on the concept and design phases, giving not only advices but also providing necessary materials. We produce all devices and components, and if there is a need and possibility, customize them to meet individual needs. We offer startup and commissioning support, and of course, we provide warranty and service support. You can start with sending us architectural layouts. Then we can calculate air leakage of protected space for you. On that basis, we will select devices and provide you selection cards with all technical parameters. We prepare a diagram of our concept proposal. Then we consult it with designer and adjust it according to individual needs, because every project is unique. We can prepare specification of all components of the system. Once the conceptual phase is complete, if there is a need, we can prepare also written technical description. We provide electrical guidelines that includes all connections and wire types. In justified cases, we are able to perform a CFD simulation to determine the realistic pressure distribution in the staircase. According to the draft of EN 12101 Part 13, it will be necessary for buildings higher than 60 meters. Simulations are performed by our research and analysis department using software from the ANSYS package. We, as industry, are currently entering the era of digitization of building information. BIM is digital representation of all technical, physical, and also functional properties of buildings and its components. Smay is responding to the market expectations by providing libraries of our products to designers, architects, and BIM managers. On our website, you can find families of ventilation grills, smoke control ducts, air volume dampers, fire and smoke control dampers, and all types of iSWAYs. This makes it possible to build a model of the entire system in Revit software. As we approach to the end of the presentation, it is time to summarize. Our SafetyWay system means reliability. It has been thoroughly tested in independent laboratories, not only in Poland, but also in Germany. Reliability and effectiveness were tested after 10,000 door opening and closing cycles. Conducted tests showed that correctly designed system can fully comply with the functional requirements defined by EN 12101 Part 6. Operation security is also supported by automatic tests that the device performs itself every 24 hours. This was shown in the first video. The test results are stored in device memory and can be easily printed. In case of any malfunction, the system will immediately communicate the error to FAS. Moreover, all components connected in the fire bus loop are continuously monitored for power presence in the standby mode. Any failure will be immediately displayed on our control device. SafetyWay means effectiveness. Our system was installed in hundreds of buildings in Poland and Europe. As you could see before, our system is very flexible, so it can be installed in any building type. But we also specialize in skyscrapers. Today, we ensure safe evacuation in many high-rise buildings, including taller than 200 meters. Our iSWAY devices are compact units that includes all necessary components. We have built-in smoke detector, cut-off damper, anti-frost system, and we can equip it in dual intake system when located on the roof. Our advantage is also complementarity. All components are parts of one system. All of them were tested and certified together, so there is a certainty that they will perfectly cooperate together. We can offer systems that are independent to extreme temperature conditions, wind impact, and the height of building. Under all conditions, it will remain precisely set pressure over the entire height of the staircase, immediately after activation. And last but not least, we offer our support on any stage of investment process. We always try to adapt our system to the individual needs of particular project. For more information, I invite you to visit our YouTube channel. All of videos about pressure differential systems are available in English, German, and French. If you have a project that requires designing pressure differential system, feel free to send it on mail visible on screen. You can always find it in the contact section of our website. And in any technical matters, you can contact me. I am at your disposal and looking forward to start or continue cooperation. If you have more questions, our technical team will be available for you in the chat for next 30 minutes. Thank you for your time and have a good day.